While the National Electrical Code, known as NEC, does not specifically mandate the bonding of above-ground pools, it is generally recommended as a crucial safety precaution. Bonding is the process of connecting all metal parts of a pool and its associated equipment, including the pump, to a common electrical ground. This practice is essential for several reasons. Firstly, prevention of electrical shock. Bonding ensures that all metal components are connected to a common electrical ground, which prevents the buildup of dangerous voltage differences. Voltage differences can occur due to stray electrical currents or faults, and if a person comes into contact with two metal parts at different voltages, they could experience a potentially lethal electrical shock. By bonding all metal parts together, the voltage potential is equalized, thus minimizing the risk of electric shock. Secondly, protection against lightning. Bonding can help protect the pool and its equipment from damage caused by lightning strikes. Lightning strikes can induce powerful electrical surges that can travel through the ground and nearby structures. If the pool is not properly bonded, these surges can find a path through the pool equipment, causing damage or even fires. A properly installed bonding system provides a low impedance path for the lightning current to flow safely to ground, minimizing the potential for damage. Thirdly, compliance with local codes. Some local building codes may require the bonding of above-ground pools, even if the NEC does not. It is always best to check with local authorities for specific requirements. Local codes may be more stringent than the NEC due to specific environmental factors or other local concerns. Failure to comply with local codes can result in fines, delays, or even the shutdown of the pool. The NEC provides two approved methods for bonding above-ground pools. Firstly, solid bonding wire. A solid, bare copper wire of at least number 8 American wire gauge, known as AWG, is used to connect all metal parts of the pool structure, pump, and other equipment. This wire should be run continuously and without splices, and it should be securely connected to each metal part using approved connectors. The wire should be buried at least 6 inches below the ground surface, and it should be protective from physical damage. Secondly, direct metal bonding. Metal-to-metal connections are made between all conductive parts of the pool and equipment. This can be achieved using bolts, screws, or clamps. All connections must be tight and corrosion-resistant to ensure a reliable electrical connection. The metal parts being connected must be clean and free of paint, rust, or other contaminants that could interfere with the electrical conductivity. The use of star washers or other locking hardware is recommended to prevent loosening of the connections over time. If you are wiring an above-ground pool pump that is ground fault circuit interrupter, known as GFCI, protected, this provides some level of protection against electrical shocks, but it does not replace the need for bonding. A GFCI is a device that monitors the electrical current flowing through a circuit and quickly interrupts the power if it detects a ground fault. While a GFCI can help prevent serious injury or death in the event of an electrical shock, it does not eliminate the risk entirely. Bonding provides an additional layer of protection by ensuring that all metal parts are at the same electrical potential, which minimizes the likelihood of a ground fault occurring in the first place. It is recommended to bond the pump motor to the pool structure using one of the methods described above. This will provide additional protection against electrical hazards and ensure compliance with recommended safety practices. To summarize, while bonding an above-ground pool is not strictly required by the NEC, it is strongly advised as a safety measure. By bonding the pump and all metal parts of the pool, you can help prevent electrical shocks, protect against lightning strikes, and ensure the safe operation of your pool equipment. Always consult with a qualified electrician to ensure that the bonding system is properly installed and meets all applicable codes and regulations. The bonding process involves connecting various metal components of the pool system to create an electrically continuous path. This path ensures that if a fault occurs and a metal part becomes energized, the current will safely flow back to the electrical panel, tripping the circuit breaker or GFCI and cutting off the power. The key components to bond in an above-ground pool system include the pool pump motor, any metal pool components such as the pool wall or frame, metal ladders or handrails, metal filter housings, metal heaters, and any other metal equipment associated with the pool. The bonding conductor, typically a number 8 AWG solid copper wire, is connected to each of these components using approved bonding connectors. These connectors are designed to create a secure and corrosion-resistant connection that will maintain electrical continuity over time. When connecting the bonding conductor to the pool pump motor, it is important to follow the manufacturer's instructions and use the designated bonding lug or terminal. The bonding conductor should be routed in a manner that minimizes the risk of physical damage or corrosion. It is recommended to bury the bonding conductor at least 6 inches below the ground surface or to protect it with conduit or other suitable protection. The bonding conductor should be run continuously without splices or breaks. If a splice is necessary, it must be made using an approved splicing connector that is listed for direct burial. Direct metal-to-metal bonding is an alternative method to using a bonding conductor. This method involves directly connecting the metal parts of the pool system together using bolts, screws, or clamps. The connections must be tight and corrosion-resistant to ensure a reliable electrical connection. The metal parts being connected must be clean and free of paint, rust, or other contaminants that could interfere with the electrical conductivity. The use of star washers or other locking hardware is recommended to prevent loosening of the connections over time. When using direct metal-to-metal bonding, it is important to ensure that all connections are accessible for inspection and maintenance. It is also important to ensure that the connections are protected from physical damage and corrosion. Regardless of the bonding method used, it is important to verify the effectiveness of the bonding system after installation. This can be done by using a multimeter to measure the resistance between various metal parts of the pool system. The resistance should be very low, typically less than 1 ohm, indicating that there is a good electrical connection between all bonded parts. It is also important to periodically inspect the bonding system to ensure that the connections are still tight and corrosion-free. If any loose or corroded connections are found, they should be repaired or replaced immediately. In addition to bonding, grounding is another important safety measure for above-ground pools. Grounding involves connecting the electrical system to the earth, providing a path for fault currents to flow safely to ground. The grounding system typically consists of a grounding electrode, such as a ground rod or ground plate, that is buried in the earth and connected to the electrical panel. The grounding system helps to stabilize the voltage of the electrical system and to prevent dangerous voltage differences from developing. It also provides a path for fault currents to flow back to the electrical panel, tripping the circuit breaker or GFCI and cutting off the power. The grounding system should be installed in accordance with the NEC and all applicable local codes. It is important to ensure that the grounding electrode is properly sized and installed and that the connections are tight and corrosion resistant. It is also important to periodically inspect the grounding system to ensure that it is still functioning properly. If the grounding electrode is corroded or damaged, it should be replaced immediately. When installing electrical equipment near an above-ground pool, it is important to maintain a safe distance from the water. The NEC specifies minimum distances for electrical equipment such as receptacles, switches, and lighting fixtures from the pool water. These distances are designed to prevent accidental contact with energized equipment while in or near the pool. It is also important to protect electrical equipment from moisture and corrosion. Electrical equipment that is installed near a pool should be listed for use in wet locations and should be protected from splashing water. In addition to following the NEC and local codes, it is important to follow the manufacturer's instructions for all electrical equipment installed near the pool. The manufacturer's instructions provide specific guidance on installation, operation, and maintenance. It is also important to use qualified electricians for all electrical work associated with the pool. A qualified electrician has the knowledge, skills, and experience to safely install and maintain electrical equipment in accordance with all applicable codes and regulations. They can also identify potential hazards and recommend appropriate safety measures. Regularly inspect the pool and its electrical equipment for any signs of damage or wear. Check for cracked or damaged pool walls, loose or corroded electrical connections, and damaged cords or plugs. Repair or replace any damaged equipment immediately. Educate all pool users about electrical safety. Teach them to never use electrical appliances near the pool, to never touch electrical equipment with wet hands, and to never enter the pool during a thunderstorm. Post warning signs near the pool to remind users of electrical safety precautions. By following these safety measures, you can help prevent electrical shocks and ensure the safe operation of your above-ground pool. Remember, electricity and water can be a dangerous combination, so it is important to take all necessary precautions to protect yourself and others. In addition to the above-mentioned points, remember that the specific requirements for bonding and grounding of above-ground pools can vary depending on local codes and regulations. Therefore, it is always essential to consult with a qualified electrician in your local building department to ensure that your pool installation meets all applicable requirements. The electrician can assess your specific situation and provide tailored recommendations for bonding and grounding your pool. They can also perform the necessary electrical work and verify that the installation is safe and compliant. The local building department can provide information on local codes and regulations and can inspect your pool installation to ensure that it meets all requirements. By working with a qualified electrician in your local building department, you can ensure that your above-ground pool is safe and compliant with all applicable codes and regulations. This will help protect you and your family from electrical hazards and ensure the safe and enjoyable operation of your pool. Another crucial aspect of pool safety is the regular inspection and maintenance of the electrical system. Over time, electrical connections can loosen, insulation can deteriorate, and equipment can become damaged. These issues can create electrical hazards and increase the risk of shocks. Therefore, it is essential to regularly inspect the pool's electrical system and perform any necessary maintenance. The inspection should include checking for loose or corroded connections, damaged wiring, cracked or broken equipment, and any other signs of wear or damage. Any issues that are found should be repaired or replaced immediately by a qualified electrician. In addition to visual inspections, it is also recommended to have the pool's electrical system professionally inspected and tested periodically. A qualified electrician can use specialized equipment to test the grounding and bonding systems, check for stray voltage, and identify any potential electrical hazard. This professional inspection can help to identify issues that may not be visible during a visual inspection and can ensure that the electrical system is functioning safely and effectively. Regular maintenance is also essential for pool safety. This includes cleaning electrical equipment, lubricating moving parts, and replacing worn or damaged components. Proper maintenance can help to extend the life of the equipment and prevent electrical hazards. It is also important to keep the area around the pool clean and free of debris. Leaves, dirt, and other debris can accumulate around electrical equipment and create a fire hazard. Therefore, it is important to regularly clean the area around the pool and remove any debris. Furthermore, consider the use of additional safety devices to enhance the electrical safety of your pool. Ground fault circuit interrupters, known as GFCIs, are highly recommended for all electrical circuits that serve the pool. GFCIs are designed to detect ground faults and quickly interrupt the power, preventing electrical shocks. They should be installed in all receptacles, switches, and lighting fixtures that are located near the pool. Surge protectors can also be used to protect electrical equipment from damage caused by power surges. Power surges can occur due to lightning strikes, power outages, or other electrical disturbances. Surge protectors can help to prevent damage to sensitive electronic equipment, such as pool pumps and heaters. Finally, consider using low-voltage lighting around the pool. Low-voltage lighting is safer than standard voltage lighting because it operates at a lower voltage, reducing the risk of electrical shock. It can also be more energy efficient and can provide a softer, more ambient light. By implementing these additional safety measures, you can further enhance the electrical safety of your pool and protect yourself and others from electrical hazards. Remember, safety is always the top priority when it comes to electricity and water.